This video is for review quiz 1.7 and 3.6, which are on inequalities and solving them. This first question is on a linear inequality, namely x is just to the power of 1, and we can solve this very much like we solve linear equations. Get x by itself. So I'm going to distribute the negative to get rid of the parentheses here. That allows me to work with the numbers inside. And I'm going to get x's to one side and the numbers to the other side. Let's move the 8x to the right-hand side. I'm going to subtract 5 and then add 3. Okay, those cancel, of course. Now we have negative x plus 8x is 7x, greater than or equal to 9 minus 5 is 4, and then plus 3 is 7. And divide by 7, we get x greater than or equal to 1. An important thing to note is that whenever you multiply or divide by a negative number, you need to flip the inequality. I didn't here, but just always keep that in mind when you're working with inequalities. Multiplication or division needs to, by a negative I should say, needs to be flipped of the inequality. Now, x greater than or equal to 1 looks like this. We have 1. If x is greater than or equal to 1, it's going to be everything to the right of it, and it's going to include 1. So we're going to use a square bracket and continue on up towards positive infinity. Those numbers are all greater than 1. So the solution set is x greater than or equal to 1, and that looks like a here. A has the square bracket, and it goes up towards positive infinity. Let me see what I messed up here. Of course, it's type your answer in interval notation. I didn't do that. Interval notation, we start at 1, that's the leftmost side, and we go up to positive infinity. And infinity always has a parenthesis around it. We use a square bracket because it's including 1. So we need to make sure we include that. So it's going to be 1, 2, infinity, and not including infinity. And that should be correct. Yep. Okay. The next problem is a compound inequality. And whatever you can solve this the same way we did in the previous problem, except now there's 3 sides that you have to concern yourself with. If it helps, just kind of ignore this, ignore one of the 2 sides and just solve this like you would a normal inequality. Get x by itself. So I'm going to subtract 5. That gives me 1/3 x, then minus 3. And to get rid of the 1/3, I'm going to multiply by 3. That allows me to cancel out the 1/3, giving me negative 9 greater than or less than or equal to x. And then this third side, just whatever you did, do it to that side as well. So the first thing we did was we subtracted 5. We get minus 2. And then we multiplied by 3. So we get negative 6. So x is bounded between negative 9 and negative 6. So we have 0 here, 1, 2, 3, 4, 5, 6, negative 6, 7, negative 8, and negative 9. It includes negative 9, but it does not include negative 6, and it's bounded between those 2 sides. So our interval notation then is going to be from negative 9 up to negative 6, and not including that. Make sure you start with the lowest number. That could be negative infinity if you start with, or some negative number, or some lower positive number. You start from the left-hand side, and then you get the rightmost number. So that could be like in this case negative 6, or it goes off to positive infinity like in the previous problem. Whatever you have to do to get the interval notation correct. But that is the correct way of writing that. Make sure. And that's correct. Okay, here we have an absolute value inequality. So the first thing we need to do is get the absolute value by itself. So I'm going to subtract 6. Just greater than. And then that's going to be negative 14, or sorry, positive 14. Then we can divide by 2. That gives us the absolute value by itself. And now we can start analyzing this absolute value. So if the absolute value is less than a negative number, that would be no solution, because absolute value means distance, and distance can never be less than a negative number. If the absolute value is greater than a negative number, so this one's like absolute value of x less than -1, this would have no solution, the empty set. If the absolute value of x is greater than a negative number, this is infinite solutions. That's because every distance is greater than a negative number. This one, we have the absolute value is greater than a positive number. So this one we can actually solve using the normal method. The way you do that is you split this up into two linear equalities. It's going to be the inside, which is 2x minus 9, and the same inequality, and then the same number, so 7. Then we can also split this, we split this up into the exact same inside, then the flipped inequality, so negative or less than, and then the negative of that sign. So the first equation, or the first inequality I should say, is the exact same thing as the absolute value, except without the absolute value signs. The next one, you're going to change the inequality and then make the number a negative. That's how you handle these things in general. So we're going to solve this the way we normally solve a linear inequality. Get the x by itself. It's going to be 16 divided by 2. X is greater than 8. Here we have -7 plus 9, so this is going to be 2 divided by 2. X is less than 1. So we have two separated inequalities here. X is greater than 8, so 8's up here. X is greater than it, so it's going to be a parenthesis because it does not include 8. Then x is less than 1, like that. So that's what we have here. All right, so I forgot to write one here. What's the interval notation? The leftmost value is going to be -infinity, because this part here goes off down towards -infinity. It just keeps going down. So that's the leftmost part, and this thing ends at 1. So we're going to say -infinity up to 1, and these are disjoint. This portion right here is not included, but it's in between them, so it's called disjoint. To write this as one set of interval notations, we do this by unioning these two sets together. Then the leftmost for this side, for this orange side, that's going to be 8, and it goes on up to +infinity. So you have these two disjoint sets that we have to combine together, and you do that with the union. All right, -infinity up to 1. That's what this u is for, the union. 8 up to infinity. Check. And that's correct. All right, this is a polynomial inequality. That's the next one here. And to solve a polynomial inequality, what you need to do is find the boundary points. Boundary points gives you the intervals that you can test, and then you can figure out which one you want. So for this thing, the way you find boundary points is you factor everything. And you need to make sure it's equal to 0, or it's less than or equal to, or greater than or equal to, or greater than or less than, whatever sign you have there. 0 has to be on one side of the inequality. And now we can factor the left-hand side. We can take out just an x. Gives me 5x minus 8, greater than or equal to 0. And this is completely factored now. There's nothing else I can do. I have two linear terms. So the solutions of this thing, if this was equal to 0, the solutions of this are the same as the boundary points to the inequality. So this thing is 0 when x equals 0. That's the first solution. And then we also have 5x minus 8 equal to 0. We're going to add 8 and then divide by 5. that just gives us x equal to 8/5. So x equal to 0 and x equal to 8/5, these are our boundary points. The intervals then that we're looking at is the lowest thing is negative infinity, as always. And the first number you hit as you go left to right is 0. 8/5 is greater than 0, so you're going to go like that. In this case, we will include the endpoints. That's because this is greater than or equal to. So we're going to include the boundary points. That's not always the case when you're dealing with rational inequalities, because you can have division by 0. But this one, there is no worry for that. The next interval that we have is from 0 up to 8/5. There we go. And the last interval to test is from 8/5 up to positive infinity. Infinity always has a parenthesis next to it. So we have 0 here, 8/5 here. And these are the three intervals we're testing. And so what we're going to do is we're going to just choose a number in these intervals and plug it into this inequality here and see if it's true or not. Or you can see if it's positive or negative, that kind of thing. So I'm going to test, we can test any number. You can test a very large number, that would be very easy to do, but I can just test -1. So we have -1, which is just plugging in right here, x and x. -1, 5 times -1 minus 8. This gives me -1 times -5 minus 8. -13, which is positive 13. So this is a positive interval. Now we can test +1, which is going to be something like here, I think. Right? So we have 1, 5 times 1 minus 8. It's going to be 1 times 5 minus 8. This is -3. -3 times 1 is -3, which is a negative interval. And finally, we can test, I don't know, we can test like 10 or something, whatever numbers on this in this blue interval. So testing 10, we get 10, 5 times 10 minus 8 gives me 10, 50 minus 8, whatever that is, that's going to be positive. I know that for sure because 50 minus 8 is not going to be negative. And positive times positive is positive. Also, whenever you have a polynomial inequality like this one is, not a rational. Rationals can change, so it's best to check all those, but it'll always go positive, then negative, then positive, then negative, then positive, however many intervals you have. You really only need to check one of them, and then it'll always flip. So this is positive, this one's negative, and that one's positive. And what's the solution set? We're looking for when is this thing, this polynomial, greater than or equal to 0. Then, in other words, when is it positive or equal to 0? So the yellow and the blue are when it's positive. So those are the intervals we want. So let me make some room here. We can then write our interval notation as going from -infinity up to 0 and including 0, right? It's greater than or equal to. Oh, no. I wrote it wrong, actually. It's just greater than. That's my bad. So it's not going to use square brackets. We're going to use parentheses. Sorry about that. Let me just change these over to parentheses. These should be parentheses. And this one should be a parenthesis as well. However, our answers are still going to be the same sets, just not including the endpoints. Again, that's because we had strict inequality here. Greater than is only allowed. Okay, those are the intervals. Solution set from -infinity up to 0, unioned with 8 over 5, infinity. Now, there's a lot of parts to this, so it's quite easy to make a single error like that. I'm glad I caught that, because I would have had it wrong in the end, and then I'd have to figure out what I did. Just like right here, I accidentally deleted the 0. So there's a lot of ways to get this wrong, so you got to be careful, and it's better to double check yourself and keep double checking yourself for what you're doing. I think this is all correct now. And of course, the interval, I kind of already showed you it. It's going to be this one and this one. So that's going to be, let's see, 0 is allowed here. That's going to be F here, I believe. Check it. And it's all correct. So double check your work, make sure everything's correct. Definitely double check the greater than, less than, all those things, because that's very easy to just, like I just did here, make an error with that. All right. Next one is a rational inequality. Same kind of process. We're gonna find the boundary points, and you do that by factoring. This one is already factored, so we don't have to worry about that. But just like you did in P.6, factor everything, like you would normally do with polynomials. So once you have everything factored, the x plus 11, this is the same thing as saying x equal to negative 11. That's our first boundary point. I'll say boundary point is negative 11. And then this one here, x minus 13, that is x equal to 13. 13 minus 13 is 0, so we get that. And then x plus 9, that's going to be negative 9. Negative 9 plus 9 is 0. We also know that x cannot equal negative 9 because it's in the denominator of the fraction. So because this thing shows a greater than, a less than, or equal to, that means you would include the boundary points. However, we will never include this boundary point because it gives us 0 in the denominator. So always keep that in mind. It's going to come into play when we start writing out the intervals and that kind of stuff. Okay, so we have 4 intervals here now. We have, let's see, negative 9, negative 11's down here, negative 9's pretty close to it. And we have like 0 is like here, then 13's way up here. So we have 4 intervals. Oh, no, the 0 is not a boundary point. My bad here. It's all of this interval is one boundary point. I just wrote 0 for the fact of having 0 in there. And in the green, yeah. So we've got 4 boundary points we're going to be working with. Or sorry, 4 intervals that we have to test. So we need to figure out a number in each one of these and then test that. So we can do something like negative 20, negative 10 works, negative 1, or probably positive 1 actually would be even easier to work. And then, I don't know, positive 20 down there. So plugging those numbers in, we get negative 20 plus 11, negative 20 minus 13, over negative 20 plus 9. This portion is going to be negative. Negative 20 plus 11 is negative 9. This is going to be positive here. Or sorry, negative as well. And this is also going to be negative. So we have a negative times a negative divided by a negative. Negative times negative is positive, and positive divided by negative is negative. So I don't actually have to look at the number itself. All I care about is the sign. So if you can test it and figure out what the sign is, then you're good to go. Now we have negative 10 to test here. Negative 10. This first one's going to be positive. Then we have a negative, and we have a negative. Positive times negative over negative. 2 negatives cancel, giving me a positive for that one. Again, you can just plug in the numbers, you can calculate it out, find the actual number. The number doesn't matter though. What we want is the sign. That's going to tell us if the interval is what we want or not. We have 1 now. So we get a positive times a negative over a positive. 1 negative makes the whole thing negative. And finally, we can test positive 20. We get positive times a positive over a positive. So it's going to be positive. So this one actually worked out to where it alternated, just like the previous one. I don't believe it'll always do that. There's some rare cases. I think it will it'll have the same one, like positive, positive, and then it'll alternate. But just it's better to just to check to make sure. All right, we are looking for when this rational equation, rational inequality, is less than or equal to 0. So boundary points are included, except for the boundary point cannot equal -9, or we can't have x equal to -9. So it's less than 0 when we have a negative. So in other words, the yellow interval, it's going to include -11, and the blue interval. We do not include -9. -9 is one of those that we can't include, so we're going to use a parenthesis. But we will include 13. So that's our interval that we're looking at. Right, it's going to be include -11 on down to -infinity, unioned with -9, but not including -9 because it's 0 in the denominator, and up to positive 13. So the solution set, -infinity to -11, -9, yep. C is the correct one there. And it's all correct. Once again, there's a lot of parts to this, so it's pretty easy to get it wrong if you don't double check yourself. Okay, last one. Going to be this word problem here. We have a ball that's thrown straight up from a rooftop at 100 feet with initial speed of 112 feet per second, and this function, we'll talk about functions more in a later video, but this is just a formula for finding the ball's height. This is the ball's height, s of t, and t, the variable t, is time after it was thrown. And it's asking during which time will the ball's height exceed that of the rooftop. Now this equation actually comes from a physics equation called the kinematic equations. You took a physics class, a first year in physics, you'd understand how to find out this equation just with pieces of information like gravity, the height of the ball, those kind of things. Okay, we're looking for when does the ball's height, s of t, exceed, so when does s of t exceed that of the rooftop? The rooftop height is 100 feet. It's got it written right. Rooftop is 100 feet high. So when is the ball's height, s of t, greater than 100? In other words, if this is the ball's height, s of t, we just plug that into our s of t there. -16t squared plus 112t plus 100 greater than 100. I can get equal to 0. -16t squared plus 112t greater than 0. Okay, this is I did a similar problem just a few problems ago. I'm going to factor this. I can take out, I don't know if 112 can be divided by 16. It can, so I'll take out a -16t. That gives me t minus 7. Make sure that works out. Yes, okay, perfect. Greater than 0. The boundary points are when this thing equals 0, which is t equal to 0. And when this thing equals 0, t minus 7 equals 0 when t equals 7. So I have two boundary points, so therefore 3 intervals, 0 and 7. And we're asking during which period does the ball's height exceed that of the rooftop? In other words, when is it positive? So for which interval, when is it positive? Now, we don't actually need to test this. I will just for the sake of continuity, but it should be understandable that it's going to be between 0 and 7. That's because the ball was first thrown up at time 0. And so of course that's going to be when it's above the thing. And if 7 is the next boundary point, then it stands to reason that 7's when it comes back down and hits the rooftop. But just to kind of keep continuity with what we did previously, let's test our intervals. We can test -1, +1, and something like 10. -1 gives me -16 times -1, -1 minus 7. Negative times negative is positive. This is a negative as well, so it's going to be negative. All right, test +1. We're going to have negative times a positive, which is negative. And this is also negative. So we have a negative times negative, positive. Again, if this doesn't make sense, just multiply it all out and find the number. You're going to see it's going to be some positive number. The actual value doesn't matter, just the sign of the number. Finally, test 10. We have a negative times a positive. This is also positive. Negative times positive is negative. We're looking for when is it greater than? That's when it's positive. And that's only during the period of 0 to 7. So between 0 to 7, and we do not include it. That's because it said during which period will the ball's height exceed that of the rooftop. If we included the endpoints, that's when the ball's height exceeds or is the same as the height of the rooftop. So between 0 and 7, excluding that, and that's correct.